Homework 1. First part. Introduction, successful code, and simple Python and NumPy function. This Python function is a simple example function that calculates an identity matrix. This function returns 5 multiply 5 identity matrix, and part 2, part 2.1, plotting the data. This function def plot data function is defined, and this function will do plotting data points and adding labels on the axis. 1. The line fig equal pyplot point feature creates any features. 2. Inside the function, the line pyplot point plot plots the x and y data points with red circles. It determines the size of the signs with ms equal 10 and sets the h color of the sign to black with mac equal k. The line pyplot point x label adds a label for the x-axis, which is set to population of city in 10,000 s. For the line pyplot point y label adds a label for the y-axis, which is set to profit in $10,000. 5. The pyplot point show line displays the plot. 6. When you call this function, the plot data function creates a chart that plots the data points and display x and y axis labels on the chart. 7. This shows x and y data points in a graph with red circular markers, with the x-axis labeled population of city in 10,000s and the y-axis labeled profit in $10,000. Then part 2.2 gradient descent and 2.2.1 update equations. Then 2.2.2 and 2.2.3 computing the cost. This code function calculates the cost for linear regressions using given input data and regression parameters. It calculates the cost of the linear regressions model used to best describe the data. Step-by-step explanations. 1. The function def compute cost is defined, and this function will calculate the cost using the regression parameters along with the given input data. 2. The m equal y point size line determines the number of data points and assigns that number to the variable m. This shows how many samples are in the dataset. 3. The line j equals 0 initially sets the cost to 0. 4. The line predictions equal x point dot data calculates the predictions made by the regression model. Predictions are calculated using the x data matrix and theta parameters. 5. Squared errors equal Line 2 calculates the squared difference between each prediction and the actual value. This is where the squared error is calculated. 6. The line j equal divide in parentheses 2 multiply mp point sum determines the cost by calculating half the average squared errors. MP point sum, the numpy function, calculates the sum of squared errors. 7. And finally, the calculate cost is stored in variable j and returned to the function with the return j line. This one successful code. And 2.2.4 gradient descent. This Python function learn linear regression parameters using gradient descent. Step by step explanation. 1. Def gradient descent function is defined, and this function learns linear regression parameters using gradient descent. Gradient descent updates parameters to best described data points. 2. The line m equal y point shape determines the number of data points and assigns that number to the variable m. This shows how many samples are in the dataset. 3. The data point copy line creates a copy of the data array so as not to replace the original data array. This is important given that numpy arrays are passed by reference when referencing function. 4. The j history equal line creates a Python list to store the value of the code function at the end of each iteration. 5. Performs gradient descent through num iter steps using a loop. 6. X dot theta is used to calculate the estimates. 7. Actual values are subtracted from predictions to calculate errors. 8. Errors are used to calculate the gradient. 9. Theta is updated using gradient and learning rate alpha. 10. At the end of each iteration, the value of the cost function is added to the j history list. And 11. When the iterations are complete, the function returns theta and j history. Successful code. Visualizing and 3.1. 1. The def feature normalize function is defined, and this function normalizes the dataset. 2. The line x norm equal x point copy creates a copy of the dataset. 3. The lines mu equal mp point zeros and sigma create arrays of zeros to store the mean and standard deviation values. The expression x point shape represents the number of features in the dataset. 4. In the main part of the process, normalization steps are performed. First, the mean value for each feature is calculated into mu array. Then the standard deviation value for each feature is calculated into the sigma array. 5. Then, for the normalization process, each feature needs to be done separately on each sample. Therefore, the expression x mu subtracts the mean value for each feature and divides by sigma. 6. Normalized data is returned along with mean and standard deviation values. And 7. This function can be used to perform data normalization and can achieve better results for many learning algorithms. And this code 3.2 gradient descent. 1. The def compute cost multifunction is defined and this function performs the cost calculation for the multivariate linear regression model. 2. The line m equal y point shape determines the number of data points and assigns that number to the variable m. 3. The line j equals 0 initially sets the cost to 0. 4. In the main part of the function, the following steps are performed. The line predictions equal x dot data calculates the predictions made by the regression model. Predictions are calculated using the x data matrix and theta parameters. Squared errors. Line 2 calculates the squared difference between each prediction and the actual value. This is where the squared error is calculated. The line j equal 1 divide in parentheses 2 multiply m multiply mp point sum determines the cost by calculating half the average squared errors. MP point sum. The numpy function calculates the sum of squares error. The code just below. The function def gradient descent multi is defined and this function uses gradient descent to learn the parameters of the multivariate linear regression model. 2. The line m equal y point shape determines the number of data points and assigns that number to the variable m. This shows how many samples are in the dataset. 3. The theta equal theta point copy. Line creates a copy of the theta array so as not to replace the original theta array. 4. The j history. Line creates a Python list to store the value of the cost function at the end of each iteration. 5. Performs gradient descent of num iter steps using a loop. 6. The line predictions equal x point dot theta calculates the predictions made by the regression model. 7. The line errors equal predictions. Y calculates the difference between the predictions and the actual values. 8. Gradients equal 1 divide m multiply x point t point dot. Line calculates the gradient. The gradient is calculated using the transpose of the data matrix by the matrix multiplication of the errors. 9. Theta equal theta alpha. Gradient line updates the theta parameters using the gradient with the learning rate alpha. Next part 3.2.1. This code includes learning the regression parameters and making a prediction using gradient descent for a multivariate linear regression model. The prediction step is performed with the x prediction dot line. Here, x prediction represents a vector file with normalized data. Theta includes the learned regression parameters. The dot product of the vector gives the result of the prediction. As a result, the estimate house price is printed on the screen. 3.3 This function calculates the closed form solution for linear regression using normal equations. Normal equations are used to find the linear regression parameters that best fit the data. 1. The function of normal equation is defined, and this function calculates linear regression parameters using normal equations. 2. The line theta equal MP point zeros initially creates the theta vector from zeros. This vector stores the learned regression parameters. 3. The calculate regression parameters using normal equations. The following steps are performed. The expression x point t point dot calculates the dot product of the data matrix x with its transpose. 5. The MP point lineal g point pinway function calculates the matrix inverse. This is used to calculate regression parameters using normal equations. 6. The expression calculates the dot product between the transpose of the data matrix x and the target values y. 7. Combining these three expressions, we calculate the theta vector. The calculate theta value is returned. And finally, this code calculates the parameters of the linear regression model using normal equations, and then makes an estimate price of a particular house. Prediction is done with the x prediction dot line. Here the prediction is calculated using the x prediction vector and the learned theta parameters. As a result, the estimate house price is printed on the screen. This code demonstrates calculating and estimating regression parameters using normal equations. It is used to find regression parameters using normal equations as an alternative method to iterative methods such as gradient descent. And finish.